Many people believe that wireless earbuds like AirPods emit harmful radiation simply because they sit so close to the brain, but the physics tells a different story. In this video, we'll break down the actual frequencies, power levels, SAR values, and electromagnetic behavior of AirPods using real engineering data. And by the end, you'll understand why the energy emitted by these devices is thousands of times weaker than the devices you already use every day. Before diving into frequencies and power values, we need to understand one key concept. What counts as harmful electromagnetic radiation? Radiation only becomes biologically dangerous when it is ionizing, meaning it has enough energy to break chemical bonds inside cells. And the frequencies used by Bluetooth devices are far below that threshold by millions of times. Bluetooth devices like wireless earbuds operate using ultra-low power radio waves in the 2.4 GHz ISM band, the same frequency range used by Wi-Fi, wireless keyboards, and baby monitors. But despite using the same frequency, Bluetooth transmits with extremely low power, usually between 1 and 2 milliwatts, far below a Wi-Fi router or even a smartphone searching for signal. To maintain a stable connection, Bluetooth uses a technique called frequency hopping, rapidly switching between 79 channels hundreds of times per second to avoid interference. This hopping makes Bluetooth incredibly efficient and reduces the risk of any single channel receiving continuous radiation exposure. In earbuds, the radio signal is also constrained by firmware to maintain minimal energy output, since higher power would drain the battery instantly. So the system constantly auto-adjusts the transmission strength based on distance, obstruction, and signal quality, always keeping power as low as possible. As a result, the energy emitted from an earbud is not only tiny, but also highly fragmented, dispersed, and never concentrated long enough to cause biological effects. Wireless earbuds typically transmit at around 1 milliwatt, which is so low that it barely exceeds the natural electromagnetic noise already present in the environment. For perspective, even a standard smartphone held next to your head emits more than 1,000 times the energy of a pair of earbuds. This difference becomes even clearer when we examine SAR, the specific absorption rate, which measures how much electromagnetic energy human tissue absorbs. A smartphone can reach SAR values close to the regulatory limit, around 1 to 1.6 watts per kilogram, depending on the region. In contrast, the SAR value of wireless earbuds is so low it is often below measurable thresholds, typically around 0.03 to 0.05 watts per kilogram. This is because power decreases exponentially with distance, and earbuds operate with such low power that their field barely penetrates tissue. Even when pressed directly against the skin, the electric field strength from an earbud is far below any threshold capable of causing heating, ionization, or biological stress. In fact, the heat generated by the tiny battery inside the earbud is significantly higher than any heat produced by radio waves. Let's compare AirPods with common household devices to put their power into perspective. AirPods transmit around 1 to 2 milliwatts of power at 2.4 gigahertz. A smartphone searching for signal can emit up to 2 watts, which is more than 1,000 times stronger than the earbuds. Wi-Fi routers typically transmit 100 to 200 milliwatts continuously, creating a larger EM field in your environment. Smartwatches emit between 1 and 10 milliwatts. Again, only a fraction of a phone's power. And even a microwave oven emits at the same 2.45 gigahertz frequency, but its power is around 700 to 1,200 watts, literally hundreds of thousands of times stronger than AirPods. So when you consider actual energy output, exposure time, and distance, AirPods are by far one of the lowest power EM devices we use daily. AirPods operate in the non-ionizing portion of the electromagnetic spectrum, which means they cannot break chemical bonds or damage DNA. Their 2.4 gigahertz radio waves are absorbed very weakly by human tissue, with penetration depth limited to a few millimeters. Power dissipates exponentially with distance, meaning the tiny emissions from AirPods lose energy almost immediately. Even with earbuds pressed directly against the skin, the electromagnetic field strength is far below any threshold capable of heating or stressing tissue. The primary source of heat in earbuds comes from the tiny internal battery, not the radio waves themselves. This combination of low power, non-ionizing frequency, rapid energy dissipation, and firmware-limited output ensures AirPods are biophysically safe. To summarize, AirPods emit extremely low-power 2.4 GHz radio waves, operate in the non-ionizing spectrum, and their SER is far below smartphones or regulatory limits. Distance, firmware control, and rapid signal hopping further reduce exposure, making them one of the safest EM devices you can wear. For healthy usage, follow simple guidelines. Keep volume moderate, take breaks during long listening sessions, and maintain device hygiene. Using AirPods for daily listening is safe. Physics, electronics, and biophysics all confirm it. Now you know the science behind why AirPods are safe. Subscribe for more tech explanations and engineering breakdowns.